put up my video.
Okay. Yeah, this is the Math 1401 Zoom meeting for March 8th, covering section 6.1 this week. I hadn't mentioned it to anybody, but tomorrow is a school vacation day. No assignments are supposed to be given and no Zoom meetings or anything supposed to be held. Now that doesn't affect this class because we've not been holding Zoom meetings on Tuesdays anyway. So I'm still, giving out the assignments first of the week, and y'all can work on them as your schedule. So if you want to take your full school break tomorrow, help yourself. Don't do a thing with school tomorrow, and you'll have taken your break. I don't know if y'all realize that. They're not given a full week spring break this semester. Yeah, tomorrow is a school. Yeah, you can look on the calendar for spring. Tomorrow is a break day. And there's two other break days, April 1st and 2nd. That's a Thursday and Friday, 1st of next month. And those 3 days are supposed to be our spring break for this semester. Great. Did you have any questions that you wanted to ask, or do you want me to just start into the assignment and explain what 6.1 is about?
Yes, please, sir.
Okay. So yeah, 6.1 is kind of, we're going to be lumped in with chapter 7 for its test. It's about discrete probability distributions, practice problems 5 to 31 odd, not for grade. Quiz on Friday to Sunday will be based on them. On the MyLab, again, study plan all chapters. Under this heading, 6.1.5, 6.1.7. And under identify discrete probability distributions, got these problems. I think I picked out 12 total. I've emailed this out and posted it, D2L. So under this heading, 1.1.19 and 6.1.21, under interpret the mean, these three. So I counted them up and hope there's 12. And just email me the percent of those 12 problems that you get correct. So 6.1 is about discrete. Try to see if anybody else joins us. Nobody has yet. Discrete probability distributions. Hope you remember what discrete meant. Saw it in chapter 1. Discrete meant it was counted with whole numbers only. No fractions or decimals allowed. So we only deal with situations where it only makes sense to have only whole numbers. Can't have 1.5, 3.6, not allowed. Yeah, so 1.5, 3.6, et cetera, these kind of numbers just not allowed. Whole numbers only. Okay, so if I was in class, I usually run a survey. Try to explain where these things come from. They come right out of chapter 2. I think I'll just make up some data. So here's some data. A favorite survey is to ask how many people, how many TVs people have in their house. Since I don't have a lot of people here at this meeting.
I have one.
You have one? Okay, very good. So do I. I have one. And so that will be a very interesting distribution. I have met people who have 9 or 10. It's like they live in a sports bar. But I'm just going to make up a few numbers, and then we'll make up the distribution. So let's say I got somebody with 2 and 3, and another 2 and 5 and 4. Somebody with 6, 2 and 1. I'll do another column. 5 and 4, 3 and 2 again. All right, we'll just go with something like this. Do you happen to notice the number that never comes up? I don't think I've ever had this number come up.
7 and 9.
No, 0.
Oh, 0.
Yeah. Everybody has a TV. Okay, so number of TV. This is right out of chapter 2. I like to go through it just to remind everybody, you know, what we did in chapter 2. Get you ready. It'll keep you kind of fresh and up for the final exam. Number of TVs. So we've got to have examples of each of these numbers. Let's see, we got 2s and 3 and 4, 5. I forgot 1. All right, sorry. 1, 2, 3, 4, 5, and 6. And then you got your frequencies, which is the number of these numbers. So there's 1, 1. There's 1, 2, 3, 4 twos.
4, yes.
Yeah, 4 threes. 1, 2 threes.
3.
Yeah, 2 threes.
Yeah, 2 3.
4. I think there was 2 4s.
Mhm.
I think I got a 5, 1 5. No, 2 5s.
2 5, yes.
And 1 6.
1 6.
Okay. So then remember you have your relative frequencies. So this means we count how many numbers there are. 5, 7, 9, 11, I believe 12. Yeah, it makes sense. There's 12 numbers there. So we divide each of these by that total. One divided by 12, 0.08. 4 divided by 12, that's 1/3, that'd be 0.33. Next are 2 divided by 12, 2 divided by 12, that's 1/6, is 0.1. So we'll call them 0.17. 0.17, and then 0.08 again for the 1 divided by 12 be 0.08. Okay. 4, 6.1. We rename first column X. That would be this one. Call it X. And we rename, period there, P of the relative frequency column. Relative frequency column P of X. That would be this one. P of X. So I'll redraw both of those columns, pick them out. X, 1, 2, 3, 4, 5, and 6 versus P of X, 0.08, 0.33, 0.17, 0.17, and 0.08 again. P of X is equal to the probability X assumes its value. 6.1 starts here. This is where your 6.1 problem, they're going to start with similar tables, whole numbers, integers, and then probabilities, and they're really relative frequencies. 8% chance somebody had 1 TV. Also an 8% chance someone had 6 TVs, at least in this survey. Okay, so then the homework for these kind of problems is going to start. They're going to ask you questions about this. It's going to start off pretty simple. Example. I guess we'll call this number 1. Find the probability a person has 2 TVs so that X equals 2. Well, can you tell the chance or probability someone has 2 TVs would just be
3.3. 0.33.
0.33. Should we put a whole bunch of those problems on the test?
Yes.
Okay. So then they I don't know, more complicated, but they ask you about multiple lines. So they might have find probability someone has from x equals 2 to x equals 4 TVs. Now this would break down to be, say, the probability of 2 TVs plus the probability of 3 TVs plus the probability of 4 TVs. And you can see the numbers. 0.33, add 0.17, add 0.17. Comes up. .67. Notice the answer is between 0 to 1, as it should be. All probabilities lie between 0 and 1. Questions about that?
No, Professor.
Okay. Then they'll ask inequalities. So like they might say, find probability someone has less than or equal to 2 TVs. Well, for this data, that would be the probability of 1 TV plus the probability of 2 TVs.
Yes.
So that would be 0.08 plus 0.33, which would be 0.41.
Yes.
And then they might say, what's the probability, or find probability at least 5 TVs. Well, for this data, that would be a probability of 5 TVs plus the probability of 6 TVs. See, at least 5 would be 5 or bigger.
Okay.
That's going to be the same answer, 0.17 plus 0.08. No, actually not the same answer, I'm sorry, 0.25. Sometimes just see the words at most used. Find the probability at most 1 TV.
That would still be 0.1.
That would just be probability of 1. 1's the biggest there. You'd be, below 1 up to 1. So this say just be 1, which would be 0.08. All right, questions about that?
No, Professor.
Okay,
That's
so
correct.
you find a lot of those kind of questions, and they're pretty simple. So then we want to find the mean number of TVs. All right, so that they use this symbol for mean.
Yes.
And for a mean and average, remember that means average.
Yeah.
You're supposed to add up the numbers. This symbol means add. And you're supposed to divide by the number of numbers.
Yes.
Well, the problem is you weren't really given the number of numbers, or really the divide by the number of numbers is buried in this probability. It actually occurred when you divided by the 12.
Yeah.
That's when you divided by the number of numbers. You divided each, adding them all up and then dividing the whole thing by the number of numbers is equivalent to dividing each one by the number of numbers.
Yes.
So all you have to do
It's multiply.
multiply by the P of X on each row. So the scheme is take X, multiply by P of X, and add up. Add up for each row. I'm off the screen. Add up for each row. For this data then, that means, so if I keep the table up, okay, so I take, in effect, 1 times 0.08, add 2 times 0.33, 3 times 0.17, 4 times 0.17, 5 times 0.17, and 6 times 0.08. All right, and you just punch away. You don't really have to punch the 1 times 0.08. That's 0.08. 0.08 add 2 times 0.33. Okay, then add, and you just keep adding up. 3 times 0.17. Add 4 times 0.17. Add 5 times 0.17. 6 times 0.08. 3.26. So the average number of TVs for this data and these probabilities, the average number of TVs is 3.26. Questions about that?
No, Professor.
Okay. Well, I know you're dying to know what the standard deviation of the data is. The suspense must be killing you. Gotta know the standard deviation. So you gotta have the mean. Remember what standard deviation was?
Yes.
Average distance, standard deviation was average distance of each of these X values from the mean, which would be 3.26, which is in here. Average distance of each of these numbers from that mean. I'll write out the scheme. We'll use, again, S squared. It starts with variance. Again, this is a repeat of chapter 3. And you go, the difference of this is the data, minus mean. You got to turn it, square it to turn it positive. This adds it up. And again, you got to divide by the number of numbers, but that's buried in the P of X. So this is, you see how much fun this is going to be. We've got to do this for each row. So we're going to start off with the 1, that's the X. 3.26 is the mean. Square it times 0.08. The P of X. Have we lost anybody?
No, not at all.
Okay. We're going to have to do this and add it up for each row. So we got 5 more to go. Next row has 2 minus 3.26 squared, 0.33. The idea, I'm taking this X minus the mean of 3.26, put in parentheses, square it, times that 0.33 corresponding to the 2. Plus 3 minus 3.26 squared, and it's 0.17. Are we losing anybody?
No.
Screen. 3 more to go. See how much fun this is? 4 minus 3.26 squared, also 0.17. 5 minus 3.26 squared times 0.17. And then 6 plus 6 minus 3.26 times 0.08. All right. I'm going to punch away. 1 minus 3.26, square it, times 0.08. Now, I could go ahead and add and then keep going, but I've discovered it just creates gibberish on the screen because you get off different lines and the like. So, you do it any way you want, but I like to hit enter, so I got that number. All right, then I'm going to add, and you see, to me, I can keep better track of it. 2 minus 3.26, then square it times, what was it, 0.33. And add. Okay, so I'm accumulating each one. So I've got the first two done and I've accumulated to 0.9325. Everything okay?
Yes.
4 more to go. It really isn't hard. It's just kind of long, kind of a
Yes. Takes
PITA.
time.
Yeah.
Yeah.
Plus, all right, third row is 3 minus 3.26 quantity squared times that's 0.17. 7. All right, I'm up to 0.944 plus 4 minus 3.26 squared, also 0.17. I'm up to 1.0731. So down to here, I'm 1.0371. 2 more to go. 5 minus 3.26 squared times 0.17, 1.55. One more. 6 minus 3.26 squared times 0.08. 2.1524. Now you can't forget, that's not the standard deviation. That was S squared.
Yes.
Variance. So S, which is in the calculator, we call it SX, standard deviation, actually, I'll just use S, is the square root of 2.1524. .467, we'll call it. Now, if you're out there going, isn't there an easier way to do this? Are you out there screaming, isn't there an easier way to do this?
I wish there is.
Well, I am here to make your wishes come true.
Oh, nice.
There is. And that's why I went through this, so that when I'm about to show you the easy way, and we'll have something to check against to give you some confidence in it. Back to the table. First step is to enter this data. And we're going to call this the L1 column and the L2 column, just like chapter 3, except in chapter 3, we didn't have an L2. We only had L1 in chapter 3. But this is the only chapter we're going to use L1 and L2. So if you remember how to enter data in stat mode, stat, edit. Remember how to clear it down up to there, clear and down. And L1's pretty simple, just numbers 1 to 6. 1, 2, 3, 4, 5, 6. Are we going too fast? You remember how to do this?
Yeah.
Okay. Then we're going to go over to L2 and we're going to enter the probabilities. 0.08, 0.33, 0.17, 0.17, 0.17, and finally 0.08. Okay, just like it's written on paper. Sorry about the little blip on my screen. That's just some sort of blip. If you can read the number there or not, probably can't. Hope I entered it right. Okay, think you got the numbers entered? I don't know if you're following along.
Yes, yes.
Okay. Here is the magic secret. So I'll just write this down. On calculator. On the calculator. Enter your X column, blah, 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 and your P of X column in L1 and L2. Data enter, or entry if you want. Okay, stat, hit or click or press, stat. All right, over to calc.
Okay.
Okay. This is where things get tricky. You still want to hit enter for number one. One variable stats.
Okay.
All right, but this is tricky. I have an old interface. I've got to hit L1. See, you got to make the calculator do the dance. If you just hit enter after this, that's what we did in chapter 3, and it's only looking at L1. That will not give you the right numbers.
Okay.
You've got to make the calculator do the dance we did. X times P of X, X times P of X, X times P of X. You got to make it look at both columns.
Okay.
Now, on my machine here, L1 is up here and L2 is above 2.
Yes.
Now, does yours work like mine? The newer interface, it's on rows, and I can't show that to you because I don't have a new machine. But in the new machine, I don't know which machine you have. There's like an L1 on row 1, and then you do an L2 on row 2. I think it says frequency, and then
Yeah,
you hit a
mine is
calculate.
on 1 and 2 as well.
Okay, does yours look kind of like this?
Yes.
Okay, this is the new one. Your L1 probably automatically came up, and then you got to enter an L2 here, and they're in the same spot. L1 is above both second one, and L2 is above
Number 2, yes.
number 2. Okay, and then you're gonna come down to calculate and hit enter. All right, and you'll get it. I've got to enter L1 and then a comma and then L2. This is the old interface. So I go second L1, commas above 7 on my machine, and second 2 for L2. So this is an old kind of awkward interface, and I don't have the new interface. But we should get exactly the same numbers, assuming we entered the same data. All right, so I hit enter, and do you spot your mean?
Yes.
Yep, first thing that comes up is your mean, and that is the correct mean, and we force the calculator to follow this scheme.
Yes. Oh.
Okay, so that's a simple way to do it. You just got to remember to enter an L1 and an L2.
This saves, I didn't know how to use the calculator. I bought it, but I didn't know how to use it. And I was back on the homework, so I had to do the homework. This took me almost to do the homework. Goodness, I don't even want to talk about it.
Okay.
It took me hours.
Okay. Well, the standard deviation, take a look. So we're getting a mean, that's 3.26. And if you look on the calculator, it only gives you one. Remember chapter 3, we had 2 standard deviations.
Yeah.
Here we have just one. They just give you the one standard deviation, 1.467.
Mhm.
And I believe that's pretty much what we got. Yes. There we are.
Yes.
Okay, now this example worked out pretty clean. That's good. I have, depending on rounding and the like, I have seen things not work quite so well. So I wouldn't worry about it. I would go off the calculator numbers rather than doing stuff by hand, because this is about the limit you can reasonably do by hand.
Oh, yeah.
So I have seen this get a little off some hand calculations, just depending on how things were rounded. But this one worked out pretty well, so we'll go with it.
Okay.
But that's the easiest way. I should also mention, and I think I forgot, the very first thing they're going to have you do is actually ask, let me get the data table. Yeah. I'll do it right beside it. They're going to ask, is this data valid, or is this a valid distribution? Is a valid distribution? Or verify that this is valid. All right, we did this back in chapter 5. It's the exact repeat. You check if it obeys the two rules.
Yeah.
Which means rule 1, do all the probabilities lie between 0 and 1? And you can clearly see that they do. Yes. But remember, that's not good enough. Rule 2, does the P of X's or do the P of X's add to 1?
Equal to 1.
Add to 1. Okay, well, I can punch it out. If it doesn't, it's from round off error. Let's see how close we got. 0.08 plus 0.33 plus 0.17 plus 0.17 plus 0.17 and another 0.08. Drum roll. Hit it.
Yeah.
Yes. So yeah, this will come up, and that's exactly how you verify something. Check if the probabilities lie between 0 and 1, and check if the probabilities add to 1.
Okay.
That's pretty much it. I can, over 30 minutes, I can basically work 1 or 2 homework problems to get you going, but most people don't find this a terribly hard section.
No, I'm really good. So what I'll do right now that is still fresh in my mind, because, and also I bought the Plus C Silver edition. So, but the challenge is I bought it used. They didn't set the charger. I need the charger.
Okay.
So I have just one bar left of the battery. So I want to rush and get it done before the battery dies off, and then I have to go source the battery.
Okay.
The charger. So.
All right. So yeah, maybe just to get you started on the first homework. So this is 6-1 homework. A couple of these early ones are just a little tricky, page 305. They want you to determine whether this random variable is discrete or continuous. We hit that in chapter 1. Remember, discrete is whole numbers only. Continuous would be whole numbers and fractions and decimals.
Yes.
All right. State your possible values. The tricky part comes in stating the possible values of your random variable. I'll just walk down through some of the parts of number 5. Part A. Number of light bulbs that burn out in a room with 20 bulbs. Can you spot whether that would be discrete or continuous?
To be discrete.
Yeah, it would be discrete. You wouldn't have 1.5 bulbs burn out.
Yes.
You have 1 bulb, 2 bulb. Okay. State your possible values of the random variable. This is where things get a little tricky. Well, you start with x equals, and remember, this is the number of light bulbs that burn out.
Yes.
So what do you think the smallest number of light bulbs that would burn out?
1.
Well, you could have none burn out, right?
Yes.
So actually,
yes, 0.
0, right?
Yeah.
All right, then what would be the maximum numbers?
20.
20. Now, sometimes people write it like this. Well, it must be between 0 and 20. All right. That's not the way to express it, because this would say you can use any number between 0 and 20.
Okay.
And there are infinite number of numbers between any 2 numbers.
Yes.
So you express it this way. you start with 0, then you go 1, 2. That's enough, but you do 3. You don't have to list all the whole numbers to 20, just enough to show the pattern.
Yeah.
Then you can go ... to 20. And this means follow this pattern, which means you only use whole numbers up to 20. But if you left the 3 off, I wouldn't, you could either leave the 2 off, that's fine. 0, 1, that would do it.
Yes.
Just enough to show what pattern you're using on the numbers between 0 and 20. In fact, the book just used 0 and 1. If you look at the book, they went 0, 1, then ... 20. So that would work. Okay, you want to try one like 17?
Yes, please.
All right. It's long enough that I won't copy it, at least the data. And this is a television survey. How many TVs do people own?
Yeah.
Okay, this is asked to disclose number of televisions in their house. So and they're going from 0 up to 9.
Yeah.
And here are the percentages of people who had this many TVs, which means their probabilities of having that many TVs. All right, I won't copy all that. Hopefully you can get it in front of you. Notice part A, verify that this is a discrete. You can instantly see it obeys rule 1. You want me to take the time to add them up and see if they all add to 1?
No. It's okay.
You think you got that?
I think they'll add up to.
Okay. So this is page 305, number 17, part A, verify. I'll just write the 2 rules down. You can 1, 0 is less than probability, less than 1. Sorry about that. 1 and 2, the probabilities add to 1. Okay. Now B says draw a graph. You want to see that done?
Yes, please. Using the calculator.
Well, actually, it's hard to do.
I can draw a graph normally.
That's pretty much all we'll ask you to do is draw it by hand. It's actually pretty tough on the calculator because the calculator is designed to work with formulas, not with raw numbers. It's difficult to get it to graph points. But I can show you the graph, the first 2 or 3 points without having to do the whole thing. Basically, I would draw a graph, and this is your P of X on your Y, and you're going X, and you're going 0, 1, 4, 5, 6, 7, 8, 9. And your highest probability is 0.186 there. So you can go up to, let's see, 0.1, 0.2, say. And then you got 0, 0, and you've got over 1, and you're up 0.16. And over 2, and you're up 0.26. So that's, I'm sorry, 0.26 was the biggest. My fault, I missed that, 0.26. So say 0.3 there, 0.26. 0.17. You got the idea?
Yes.
Okay. And like I say, you can get it to draw on a calculator, but I'd be here another 15 minutes showing you how. Much quicker to do it. And by the way, don't connect them. You understand why? That kind of implies you can use any number between these. So you just draw dots because that's all that's on the graph, and this just goes on.
Oh, okay.
All right, well, C is the mean. Do you want to take the time to punch the data in and get the mean?
No, I know that my daughter have been teaching me that 1 to 9 is 45.
Right, you would
So
enter this
45
in the
divided by
L1
9
column,
Yes,
this in the L2,
yes.
and you can read the mean and the standard deviation. So C and D, kind of done together right off the calculator.
Okay. Yeah.
So I'll just say C and D, standard deviation. You can read off the calculator. So you don't need to see that done?
No, we just did.
Okay. All right, so E. E is incredibly difficult.
Yeah.
What is the probability? You have 3 TVs. Got to be a real Einstein to handle this. Are we capable of this incredible mental feat?
Yeah, probability of 3
Okay.
TVs.
3 TVs. Probability would be
0.176, I believe.
0.176, exactly. What's the probability? 3 or 4?
0.176 plus the
Right,
value
0.176
for
plus 0.186, right?
okay.
3 or 4 would add them, so 3.176 and 4.186. That 0.2 something. 0.362. 36% chance someone would have 3 or 4 TVs. G, what's the probability no TVs?
That would be 0.
Yeah, that's basically 0. In this survey, no TVs is 0, and they're saying the probability of that is 0. 0.
Yeah.
Now, this is where things get tricky if you look at the next question. Is this an impossible event?
Yeah.
Well, we said if something had a probability of 0, it was an impossible event. It would never happen, right? Well, something like this, it's possible we could have someone out there with 0 TVs, right?
Yeah.
Theoretically.
It's
So,
possible, yes.
yeah. In this case, really, no, it's not impossible. Might be somebody out there who doesn't have a TV.
Yeah, I met someone that doesn't use a mobile phone, only have a land phone.
Yeah. Yeah, that was me up until probably 5 years ago. We had our landline phone. We finally ditched the landline about 5 years ago. Long way after. We're like 10 years behind everybody else. It's really amazing that phone technology, my folks, I don't know if you ever heard of a party line. My folks grew up in rural New York, and there was one telephone line down their road. And if a phone rang, whenever anybody on the road connected that line got a call,
everybody can speak it.
Yeah, everyone. It didn't just ring the person who they were calling. Everyone's phone rang. So everyone would pick up and listen. And everybody knew everybody else's business. All right, so that was that was 1940s rural New York.
Oh.
Okay. All right. So then, to my generation, we had one, and in fact, in my house here, up to like 5 years ago, we had one house and one phone in the center of the house. And so if anybody called our house, you had to go to the center room of the house and pick up the phone and talk. That was the only phone we had.
Oh, man.
Yeah. That was the landline.
Yeah.
And so we eventually ditched that. Now we've all got our own personal phone numbers, and smartphones. Oh, well, I don't know why we got into that. That's neither here nor there. Is there anything else you'd like to see? Would you like to see more problems?
No, I'll give it a shot with the homeworks. But if I run into problems, I can always, I know you're reliable. If I send you an email, It was
Yeah,
long
send me an
before.
email. And we got 2 more Zooms, Thursday at 12 and Thursday at 8.
Oh, yes. Okay. Thank you so
All
much.
right. Well, enjoy your school break tomorrow if you take it.
Okay. Thank you.
Sure thing.
I don't have classes on Tuesdays though, so
Okay.
it's not really a break. Yeah.
I understand. Yeah. It's kind of strange how you could just take one day, random day in the middle of a week and just take it off. It's just kind of strange, but that's the way they did it.
Yeah.
All right. Well, you have a good evening then.
Yes, sir. You too. Good evening. Thank you so much.
Sure thing.
Let me go do the homeworks and then the exam.
Okay. Sounds good. Good night.
Good night.
Night.